Assalamualaikum and hello everyone. Welcome back to a new video of chapter 3, which is 3.2 periodicity. As you can see here, there's a lot of learning outcome for this subtopic 3.2. But specifically for this video, what we're going to look at is actually describe the variation of atomic radii for the across a period and down a group. Okay. So first thing first, let's look what is actually atomic radii. So we're going to discuss the atomic radii. Atomic radius is taken as half a distance between two atoms. So for example, if I have two atoms here, so here is actually I'm going to take half of the distance between two atoms kan. So this is what we call as the radius lah. And the atomic radius depends on the strength of attractive forces between the valence electron and the nucleus. The stronger the attractive force, the smaller the atomic radius. Okay, why? Okay, so for example, here is our shell lah. So for the case of our nucleus, there's a proton inside of our nucleus. So that's why the nucleus itself, usually we're going to talk about, is actually a positive charge. Where the electron itself, we know it's a negatively charged species. Okay, so for the opposite charges, so it means that there's an attraction between our nucleus and our electron. Okay, so if the attraction between our nucleus and the electron or the valence electron is high, so what it means is that the electron will be pulled closer to the nucleus, hence it will have a smaller atomic size. So that is what it meant. Okay, if you were unsure, it's okay. We're going to look into detail later. Okay, so here is actually an example of atomic radii. So it's not all of the atoms. It's just a bit of a general one. Okay, so you don't have to memorize the exact number or anything. Okay, so actually from the size itself, you can see there's a trend where for across a period. So what does it mean by across a period? It means that for the same period lah. The same period. Here is same period. Okay, and then for example, so here is example of our period 2. Okay, so as you can see here, the size decreases. Okay, sometimes it is defined as atomic radii, sometimes it is defined by atomic size, so it's fine either way kamu nak guna. Okay, so here is actually the example of our atomic size across a period. As you can see, the atomic size decreases. So maknanya is on period 2 ni, kita tengok makin lama it will become smaller. Whereas down the group, again, down the group ni pun is actually we're talking about the same group. Okay, in this case, I'm going to look at for group 1. So here is actually our group 1. Okay, down the group 1 itself, as we can see, the atomic sizes increase. Okay, why? This is actually what we're going to learn. Why? Okay. So it mentioned here, there are two factors that affect atomic radius, which is shielding effect, where this is actually a dominant factor when we're discussing the atomic size down the group. Again, down the group, make sure it's the same group. Make sure same group. Whereas the effective nuclear charge here is actually what we're going to be discussing when we're talking about the element or the atoms across the period. So again, across the period, it means that it is in the same period. Okay, so now let's look for the explanation on page 6. Okay, so first I'm going to look at for the shielding effect. So again, shielding effect ni is actually when we're discussing for the atoms which have the same group. Okay, so what is a shielding effect? Shielding effect is the blocking of attraction of valence electron by the nucleus due to the presence of inner electrons. Okay, just gonna write down inner dulu. So how does it work? Is that it is because caused by the repulsion of your inner shell electron on the outer shell electron. Okay, so what does it mean? Okay, as I've mentioned before, there's actually attraction between our nucleus and our electron. Okay, because that is the opposite charge kan. But then again, for our electron itself, for example, inner electrons ni contohnya, for example here n equal to 1 ni n equal to 2. So it means that when n equal to 2 there's electron, it means that n equal to 1 pun mestilah have electron as well. Okay, what happens is that between the electron itself, there's a repulsion because it is the same charge, kan? So when there's the repulsion here, so what happens is that apa ni? The attraction between the valence electron and the nucleus itself ni is very weak lah, because there's actually inner electron ni yang ada repulsion. So that's why it is harder for the valence electron ni to feel the attraction between the nucleus and the electron. Okay. So kita assume sajalah think of a concert. For example, ini concert kat sekolah lah, ataupun siapa yang experience. Contohnya kita ada concert kat Matrix ni itself. Contohnya, okay, kita ada dewan. Of course kita ada, contohnya this is our hall tu kan, dewan kita. So sini mesti ada kita punya stage. Okay, and then sini ada orang tengah perform. So sebab kita punya sekolah ni ataupun matric kita tak adalah high budget sangat. So the speaker is actually only at the front. Kan, contohnya speaker ni ada kat depan je. Speaker ni tak ada pun kat belakang. So what happen is that actually siapa yang duduk kat depan sekali ni akan dengar lah. Akan dengar apa ni, music tu very loud and clear sebab it is nearer to the stage itself. But for those yang duduk kat belakang sekali tu, yang datang lambat tu, what happens that dia tak dengar. Okay, sebab dalam case ni, again, dia punya voice ataupun dia punya sound system tu is actually at the front je. Tak ada pun kat belakang. Okay, so sebab tu lah, dekat sini what happen is that, bila kat belakang ni, dia akan kurang lah. Maknanya, dia akan, dia punya noise tu, dia punya sound system tu tak dengar kat tempat dia. It's because that, sebab kat depan ni dah ramai sangat orang, lepas tu memang dah shielded dah kan. So, dekat belakang ni tak dengar. So, macam tu lah. So, kiranya dalam case ni, macam ni nucleus ni tengah perform, but then again, the inner electron sahaja yang dapat dengar very clear sebab it is very near to the nucleus itself. Tapi yang the valence electron, maksud dia dah jauh daripada our nucleus itself, dia akan kurang lah feel the attraction itself. So the shielded, the repulsion ataupun the presence of the inner shell ni, the inner electrons ni is what we call as shielding effect. Maknanya dia mengcoverkan attraction itself tu. Okay. So jom kita tengok how do we explain this. Okay. So here is actually the atomic radius for a given atom down the group. Ni is actually group 1 element. We have our lithium, we have our sodium, and we have our K potassium. Okay. So electronic configuration kita, if you still remember, yang 1s2, 2s1. Ni 1s2, 2s2, 2p6, 3s1. Potassium 1s2, 2s2, 2p6, 3s2, 3p6, 4s1. Okay, remember, where we fill up our electron, it must be fill up 4s dahulu. Then once the 4s is fully filled, then we're gonna fill up our 3d orbital. Okay, so sekarang ni number of shell ni is actually number of our N lah, principal quantum number tu. Okay, again, principal quantum number tu, we're gonna look lah how much do we have. So for lithium, the number of shell dia, it means that first ni ada 1, ada 2. Here is 2 electron, here is 1 electron. So for our lithium, number of shell kita, we do have 2. For the case of sodium, we have 3. And potassium, we have 4. Okay. Okay, so what happened here is that down the same group, group 1, for example, listen group group 2 boleh, group 3 pun boleh. What happened is that the number of electron shell will increase. So what happened when the number of electron shell increase, the number of inner electron pun increase. Okay, so contohnya, if we know valence electron is actually our highest end. So the one that color pink ni, this is our valence electron kita lah. So as we can see, when number of N increases, kita punya inner electron pun increase. So for example, lithium ni inner dia only 2 electron. Kalau our sodium, we have 10 electron. Kalau potassium ni, we have 18 electron. So down the group, number of electron shall increase, number of inner electron pun increase. So what happens is that the repulsion between inner and the valence electron tu will increase as well. So there's more electron kan, so maknanya between the electrons between the interaction between the electron itself, the repulsion tu will become stronger. So when the repulsion is high, so the shielding effect akan increase. Okay, so maknanya bila dah banyak dah elektron, the inner electron dah banyak, so maknanya dekat kita punya our valence electron ni pun does not feel any attraction dah. It's being shielded by our inner shell. Okay, so what happens is that the attraction between nucleus and valence electron will increase. The attraction increase pula. Sorry, the attraction tu dah decrease because it's being shielded. Okay, so kiranya kalau kita dengar konsert, kalau kita dah makin jauh, kita tak dengar lah. Itu kalau sound system dia kat depan je. Kalau sebab ada je konsert kat tepi juga Okay, so what happens is that when the attraction between the nucleus and valence electron decrease, so the atomic size will increase. Okay, remember that as mentioned before, okay, if the attractive force is strong, then we will have a smaller atomic size. Kalau we have weak attractive force, we have a bigger atomic size. Bigger atomic size. Okay. So that is actually for the case of shielding effect for down the group. Okay. So that is actually for the shielding effect. This is involving element for the same group. Next, what we're going to look at is actually for effective nuclear charge. Effective nuclear charge in this case is actually if we're talking about the atoms in the same period. Okay, so what happens is that what is actually effective nuclear charge? Effective nuclear charge is the net nuclear ataupun the positive charge experienced by the valence electron. Okay. The reduced nuclear charge caused by the blocking of Okay. Okay. The reduced nuclear charge is caused by the blocking of attraction. Okay, so I'm going to explain what is this. The attraction of our valence electron by nucleus due to the presence of our inner electrons. Okay, so ni sama juga. So the effective nuclear charge, okay, nuclear charge ni maksud dia begini, for this time around we can calculate it. So what happens is that it's actually what is the positive charge experienced by the valence electron? Actually what is the attraction tu lah. Okay, so the reduced nuclear charge ni caused by the blocking of attraction of valence electron by due to the presence of inner electron. So what happens is that again the electron ni, because there's a repulsion between the electrons themselves, so that's why there's less ataupun reduced nuclear charge. So it means that the valence electron ni experience less of our nuclear charge. Dia kuranglah rasa attraction to itself. Okay. So, macam mana kita nak buat pula? How we're going to discuss it? Yang kita boleh buat calculation sikit lah. Where ZF, effective nuclear charge, we call it as Zeff lah, senang. Is equal to Z minus S. Z is the number of proton. S is the number of inner electron. Okay, again, for here is the example of period 3 element. So here we have from our sodium until our silicon. So as we can see, the size itself is decreasing. Okay, so let's look a bit for the calculation itself. So the electronic configuration for this one, so here will become 1s2, 2s2, 2p6, 3s1. So because the number, the difference is actually we're going to add one more, kan? So here we become 3s2 Okay, 3s2. So here will become 3s2, 3p1. And then the silicon will become 1s2, 2s2, 3s2, 3p2. So when we calculate again, here is 11, here is 12, 13 and 14. Okay. So again, in this case, remember that our valence electron means the highest n. Okay, so the highest n for our case here is this one. So the pink one again is my valence electron, valence shell itself. Okay. So how do we calculate Zeff? Zeff ni the number of proton itself minus number of inner electron. So in this case, sodium number of electron dia is 11. Okay, tapi how much is our inner electron? Inner electron tu maknanya this is our valence electron. Okay, so it means that yang ini semua ni is actually our inner electrons. Okay, so 11 minus dengan inner electron kita ni. Okay. Pink ni is actually pink pula yang ni this colour tu is actually I'm talking about my inner electron. Okay, so how many inner electron? So electron kita sini 2, 4, 10. So minus by 10. So we get our Zeff is positive 1. Okay, positive remember sebab kita nak yang attraction, the effective nuclear charge ataupun kat sini the net nuclear ataupun positive charge. Sebab the nucleus itself positive ni kan. So that's why dia positive 1. So kalau magnesium 12, P minus berapa? So pun sama juga. As you can see the inner electron is the same as this one. So it's actually 10. Pun sama juga. 10. So here plus 2. So in this case our aluminium 13. Okay, minus number of inner electron. Inner electron kita pun is still the same. So here is 10. Now is positive 3. Our silicon 14 minus by minus 10. Okay, we do get positive 4. Okay, so as we can see, across the period, the same period, the number of effective nuclear charge is getting higher. Okay, why do we discuss this? So let's look here. So what happened is that across the period, the number of proton increase. Okay, remember memang the periodic table is actually arranged by increasing proton number. Okay. So what happens is that bila the proton number increase, the effective nuclear charge pun increase juga. Okay, why the effective nuclear charge increase? Sebab dia punya proton is increasing, but the number of inner ni sama sahaja, is maintain the same. Yang ni across the same period lah. Okay, so what happen next is actually bila effective nuclear charge increase, so it means that outermost electron yang sodium ni feel attraction with the nucleus is positive 1. Kalau magnesium ni positive 2. So as we can see, the attraction tu makin lama is becoming higher. Right. So what happen is that the attraction between nucleus and valence electron becomes stronger. So when the attraction between our nucleus and valence electron becomes stronger, so it may become smaller lah. So what happened? The atomic size decrease. So that's why as we can see here, across the period, based on the value itself, we can see it is getting smaller across the period here. Contohnya for aluminium dengan silicon kan, 0.143 dengan 0.117. Okay. Kalau yang ini pula down the group tadi, kita tengok memang down the group, the value will be coming, as we mentioned, the atomic size increase, the value pun, between lithium ni 0.152, sodium ni 0.186. Okay. So this is actually about shielding effect and effective nuclear charge. So this is very important when we discussing about our radius of the electron, the radius of the atom ataupun the size of the atom. So actually it always it's either these two lah. Okay, so contohnya dia memang banyak explanation, tapi nak tips nak bagi senang ingat kan macam mana. So dalam case ni, for the case of our shielding effect, so let's look here. So macam mana kita nak ingat dia shielding effect ni? Ini. NSAS. Kita buat inilah. NSAS. Okay. Tapi kalau for the case of effective nuclear charge ni, Ni saya tulis pizzas. Pizzas lah. Okay, so what does it mean by answers? Okay, so kat sini kita tengok the different the number. So what is meant by answers? N ni is actually the number of electron shell. Sorry, here is the number of electron shell. S ni we're talking about the shielding effect. A ni is the attraction between the nucleus and valence electron. And S ni is actually about the atomic size lah. Okay, so contohnya answers. Okay, so when the N increasing, so what happens is that the shielding effect akan increase. Okay, so what happens is that the attraction between the valence and the nucleus decrease, hence the size tu akan increase. Okay, yang ini pun Miss buat lah simbol dia yang bawah ni. We're going to use this color. Okay, so when N increasing, the shielding effect will increase. Okay, what happens is the attraction between the nucleus and valence will decrease. And the size itself will increase. So that is meant by answers. Make sure yang ini the difference is actually the N itself. Okay. Dalam case ni for the effective nuclear charge pizzas. Okay, why pizzas? Okay, so kita tengok when the proton number increase. Okay, P ni meant for PI ni lah boleh PI ni untuk yang proton increase. Z ni is for our Zeff, effective nuclear charge, or you could also write it as Zeff. A ni, it means by the attraction between the nucleus and the valence electron. S ni by the atomic size. Okay, so how does it work? So when the proton number increase, yang ini, PI ni proton number increase, the effective nuclear charge ni will increase. So what happens is that when the attraction between the nucleus and valence electron increase, so it means kat sini attraction between nucleus and valence electron increase. So what happen is the atomic size will decrease. Okay. Sebab nanti lagi dekat lah bila attraction tu become stronger. Kalau dia strong kan memang valence electron tu nak dekat dengan kita punya nucleus. Kalau attraction dia tu weak, dia memang makin jauh lah. So that's why lah atomic size dia increase. Okay. So there's a lot of explanation kan. Okay. So okay. Next video we're going to look at some of the example and I'm going to add examples for your quizzes as well.